Okay, so again, I picked some calculator allowed multiple choice questions that they're pretty straightforward, and I just am trying to review some of the things you can do in your calculator. All the questions from this video are from the shorter optional test that I posted on Canvas under extra practice tests, and it's just the multiple choice calculator allowed section. So that's where I got these ones from. So you can print it off from Canvas if you want to follow along on paper. Okay, so this one says at time t, the velocity of the particle moving along the x-axis is that. What is the total distance traveled by the particle during that time? So this question with your calculator should be really easy as long as you have your total distance traveled formula memorized. So the total distance traveled formula is the integral from a to b of the absolute value of velocity, and that equals the total distance traveled of the object between a and b, okay? So for this one, all I have to do is integrate the equation that they gave me from 0 to 2. That's my a and my b, the absolute value of that. Okay, so I'm gonna go math, and then I go down to integrate, and I go from 0 to 2. Then to find absolute value, it's in here in math, and I go over to number, it says ABS, that's absolute value. And then type in the equation. So that's nope, oh no, that's all right. You can see me press the buttons again. 0 to 2, math, absolute value, e to the x squared minus 2 and wait for it, and that is it. So 13.638, which is B, which is the answer. So that one's more just testing that formula. So if you have that memorized, you should be typing that whole thing in. Okay, next one. 80. It says let f be the function defined by that. For what value of x on the interval from 0 to 4 is the average rate of change of f of x equal to the instantaneous rate of change of f of x? Now this is another great example of one that I would use your calculator so that you don't get it wrong just because of algebra, okay? My average rate of change is f of b minus f of a over b minus a. Now I'm gonna use my calculator to help me with that for sure, okay? So I have the, okay, wait for it. All right, so I have e to the cosine. My b in this case is the 4. I've already double checked, you know, like 100 million times I'm in radian mode. Okay. And then I can press second entry so that I can just go in and replace those 4s with a 0. Okay. So then I can, you could have stored those, or I'm just gonna type them in this case, making sure to put in parentheses. 1.276949596 minus, now I could retype that whole thing in for the 2.718. I'm actually going to use the answer function. So if I press second, and then right here where it says ANS, that just means it takes the very last answer. That way I don't have to retype that whole thing in. And I'm going to divide that by 4 minus 0. And I'm not even doing that in my head because it is too much math. Okay, so that right there represents the average rate of change, okay, from 0 to 4, okay. Now, I'm going to go ahead and store that number in for A, because I'm going to use it here in a second. Okay. Now I need to know where that equals the instantaneous rate of change. So basically I want to know where f prime of x equals that number. Okay. So this, the derivative of this, now if I was finding the derivative of this at a certain value for x, okay, then I would definitely use my calculator to find this derivative. However, I need to know where this equation equals a number, so that is easiest to do in the graph mode. So I actually am going to go in and solve for this f prime of x equation. So this one's a chain rule. So it'd be negative sine x times e to the cosine x minus cosine x. So that inside function was cosine, outside function was e. Okay. Then I can go in here and I can put that equation into y1. Basically, anytime you need to find where two things are equal, whether it's two equations or a number in an equation, use your graph mode. And then here, I'm going to put my, wait for it. Okay, here, I'm going to put my A that I stored, that value. Okay. And I only need to worry about it between 0 and 4. So it's a good thing there's only one of those between 0 and 4. Okay, so that's the 1.901. So the answer is B. Okay. Do you want to grade right now or later?
I'll just grade it right now.
Okay. There you go. Okay. All right, so the next one I want to go over is 84. Almost done. Okay, we did one like this on the other one, but I just want to do it again. So the function f is the antiderivative of the function g defined by that. So it says the function f is the antiderivative. So basically that's telling me that g is f prime. So which of the following is the x-coordinate of the location of the relative maximum for the graph of f? So if I'm looking for the maximum of f, I'm going to look where the derivative of f is 0 and has a sign change from a positive to a negative, okay? So I'm going to go ahead and graph this equation in here in the graph mode. Oop. I always forget to press the over button when I type these in at first. Okay, so just have it there in my graph mode. Okay. And the maximum is going to happen at the 0 on the derivative, which is this graph, that changes from a positive to a negative. That's going to create the maximum on the original, because then my original goes from increasing to decreasing. So that happens on this one. This one would represent a relative minimum. Okay, so then I need to find that x coordinate there. And that's 1.312, which looks like A for this question. Okay. All right. 3 more I want to do. Okay. Let f be this next one is 86. Let f be the function with the first derivative, that. If f of 3 equals 4, what is the value of f of 6? So that is going to be what we're going to use as our initial condition, because that's the value that they gave me. So I'm going to go from 3 to 6, and I'm going to integrate that. And that equals f of 6 minus f of 3. That's our first fundamental thermal calculus. So I'm going to type this into my calculator, and then I get to just add the 4 to it. Okay. So math 9 from 3 to 6. Sine x plus cosine x plus 2. Okay, so I just typed it right in to my math 9, and then add the 4 to it from our initial condition. So that gives me 7.198, which is D. Okay. 87. The velocity of the particle is given by that. What is the acceleration of the particle at t equals 4? So the